Hello, everyone, and thank you for attending today's webinar. My name is Mike McCumber. I'm a marketing manager here at DigiFabster. We do have a great event planned for you today. We're going to have Michael Stoy, our applications engineer, presenting today's topic. The topic's going to be key features of the DigiFabster CNC module. So if you have any questions, we're going to open it up to Q&A at the end. So if you have any questions, feel free to enter them in the questions panel, and then we will answer them out loud at the end. Maybe more than just one person has that question, so we will do that at the end. And with that, I am going to hand it over to Michael for today's presentation.
Hello, everyone. And again, as Michael also mentioned, if you do have any questions, please fill out your questions in the question field on the right-hand side of your screen, and we'll answer these at the end of the call. Today, we're going to be focusing on the CNC milling module, and we're going to be walking through how to set up a machine, along with how we can break down all the machinery that you have into our tool. So before we begin actually setting up a pricing algorithm, let's look at the different types of CNCing that we can offer inside of DigiFabster. Off the bat, we typically break it up into CNC cutting and CNC turning. So if we're working with milling machines or turning machines. This demo itself, we'll be focusing only on the milling machines. Under the milling machines, we have three different categories of them. We have CNC cutting, we have 3-axis milling, and then multi-axis milling. Depending on your shop's capacity, you can enable all of these, or you can enable only one if you choose to. So let's start with the most basic CNC cutting. With this, we're cutting out a 2D profile into a part. So for example, if we're cutting out this faceplate, we would use CNC cutting. With CNC cutting, we're going to start with a fixed bar stock size. We're not going to machine the top of the bar stock at all. All we're going to be doing is cutting out the profile. So for this case, we have this faceplate. What we can do is we can choose to have it made with, let's say, 20mm thick aluminum, and then we can add the part to our cart. Next, let's go one step more complex, and we can get into our 3-axis milling. With 3-axis milling, we have a part that can be machined on a 3-axis machine with a single clamp. So what that means is once we clamp the bar stock into our part, we're able to machine it all in one setting. This differs from more complex parts because with more complex parts, we'll need additional reclamps, and that's what we'll get into our multi-axis milling. So for example, if we were to add some more holes in this part, this might not be able to be made on a 3-axis machine. So if you've noticed, we've just added 3 additional holes into this part, and because of that, we now need to move up to multi-axis milling. So even though that this part can be machined on a 3-axis machine, we're going to need an additional reclaim for those 3 holes, so it'll be moved up to multi-axis milling. If we scroll down and look at the actual features of multi-axis milling, we can choose the different materials, we can choose different tolerances, and we can even specify the hole type, so if they were threaded or regular holes as well. In this walkthrough, we're going to actually set up a multi-axis machine, and we'll recommend all the configurations for these materials. Again, as we mentioned, if you have any questions, feel free to add them into the question box above. So to start setting up a machine, what we're going to do is we're going to head over to Machines and Materials. And inside of Machines and Materials, let's just make sure that we're in the CNC module. Now what we can do is we can create a new machine. In this example, we're going to create a multi-axis machine, but if we wanted to create a 3-axis machine or a CNC cutter, we can also select one of those technologies as well. With our multi-axis milling, we can now choose our machine type. We have a list of common industry machines, but if you're using a different machine, you can always create your own. For this example, let's just choose a Haas. Inside the machine, we also have a travel. So this is the maximum amount, the maximum envelope of parts can be, prior to not being able to fit within the machine. If we want to, we also have the ability to modify this value. So if we only wanted to work with very small parts on this machine, we can decrease the travel size to a theoretical smaller value. With this, we also have a minimum part size. So with this minimum part size, we can use this in conjunction with the maximum part size to create bin pricing. So if we want to price very small parts differently than we price medium-sized parts versus how we price very large parts, we can configure that as well. If we have 2 machines and we have a small machine and a large machine, this is another way that we can direct jobs to the right machine. Next, we're going to get into our complexity bracketing. So what happens is whenever a part is uploaded, we'll automatically analyze and determine how complex the part is to machine. With this complexity bracketing, I'll recommend the following values, but these values highly are dependent on your shop's capabilities and your shop's expertise. We have some shops where how the numbers are spread can be completely different than this. So this is a great recommended starting off point, but again, don't take these numbers as the absolute values. So what happens with our complexity bracketing is whenever a part is uploaded, we'll automatically analyze and apply into different bins. So we have very simple parts, normal parts, complex, and then highly complex parts. We can create a cycle time multiplier depending on which bin the part's in. For very simple parts, a typical cycle time multiplier is typically around 1.1 to 1.2. Simple parts have a cycle time multiplier typically in around the 2 range. Normal parts are in the 4 range. Complex parts are in the 6 range. And then the highly complex are typically around the 7 to 8 range. Again, though, these values may be completely different depending on your shop's capabilities and your shop's expertise. If we're very proficient at highly complex parts, the highly complex cycle time multiplier might be slightly lower, and the very simple multipliers may be even higher. So it's a great way to help just balance out the pricing algorithm to match how your shop currently functions and how your shop currently prices parts. Now that we have our cycle time multipliers set up, we can now work on our machine specs. The first value that we have is the machine speed of the theoretical amount of material that you're able to remove within an hour. By default, this is set to with a machinability of a material of 100%, and this is based off of some ANSI standards. However, if we want to, we can also normalize this off of a different material. So we have some shops where they'll normalize all of their pricing and all of their machine speeds based on aluminum, because that's the material that they use the most. So if we want, we can also set that up as well. I recommend keeping this as 1,000 as long as we're working with industrial machines as we're starting out. If we're working with more desktop machines, the speed will be much lower. Next, we have our price per hour. And again, this is dependent on each shop and each industry. For a typical ballpark, we could say something around $150 per hour per machine. If we want to, we can have a per part fee. So this can be handling or adding the bar stocks to the machine and removing the parts afterwards. So what we can do is we can say there's a $20 per part fee, for example. And then finally, we have our manual review. So what happens is if a customer is ordering multiple of a single part, we can hold that order for review. So this just makes sure that we still have the capacity to fulfill the order in that timely manner. So what we can do is we can say maybe 100 parts. And if the customer's ordering 100 parts, we might overbook our capacity. So we want to manually review this quote prior to allowing the customer to pay. Next, we have our tolerance options. And with tolerance, we can set this up in multiple different ways. If we want to, we can have just bulk tolerances. So we can have plus minus 10 millimeters, plus minus 1 millimeter. And for this higher tolerance option, we can have a higher margin. So for example, we can have a 30% margin for plus minus 1 millimeter, and then we can allow customers to select which tolerance best fits their needs. The other option we can set up is we can set a baseline tolerance and then allow the customer to select if they want a modification of that. So we could have this be our standard tolerance, this be standard tolerance with 2 features within a tighter tolerance, for example. The other option that we can configure is we can have the tolerances fixed for each material. And what will happen is whenever the part's analyzed, it will be analyzed and only will display what the tolerance the part was analyzed for. So again, it can be configured multiple different ways. And it's up to the shop to choose which way they feel best works for them. Now we can get to our feature recognition. And with our feature recognition, what we can do is we can analyze the part for holes or other features and add additional costs for them. So let's add a hole. So what we can do is we can say any hole. Let's first make sure that we activate it. With the feature type, we're going to search on any cuboid face of the part. So we're going to select cuboid, and we can say each hole is $3 to machine out of a part. Now we can give multiple different options as well. So what we can do is we can have a threaded hole. And with this threaded hole, again, we'll search on that cuboid face. We can say threaded holes are $10 a part. So it's a great way to allow customers to select what types of holes they need on their part. And again, a lot of this information is on typically the engineering drawing, but not on the model itself. So this is a great way that we're able to analyze the models and we're able to allow the customer to select what they need for their parts. Finally, we get to our lead times. With lead times, we can have multiple different lead times with different margins. So this way, if a customer needs a part quicker, they can pay that premium to get their part quicker. In this example, what we can do is we can have a 5-day rush lead time with an additional 30% margin. So it's a great way to upsell customers if they need their parts quicker. Now what we can do is we can save our machine. We can fill this into 0. We can now save our machine, and now we can create a material. So now that we have our machine set up, we'll have all the materials that machine offers, and we can set all of these up as well. By default, we have a list of common machine metals, but if we wanted to work with plastics or any other material, you can always create your own. This example, let's just choose aluminum. So we have the material name. The material name is used in the backend to keep track of the materials, but if we wanted to, we can change the display name to end users. So if we just wanted to call this aluminum to end users, we can show that as well. We also have the ability to have notes for end users, so we can give them a better description of the aluminum or even a material spec sheet for the aluminum. So it's a great way, again, to allow customers to know what exactly they're ordering, depending on their knowledge base of machining. Now we can get into the startup costs and the programming costs. So the startup cost can be applied for every unique material, every unique execution, or every unique model. And with the startup costs, what we can also do is typically, let's say, we machine mainly out of aluminum, but if someone wants a part made out of titanium, we need to configure the machine to machine titanium. This might take an hour or two of setup or changing out bits. So what we can do is we can have in a cost for any of these specialty materials. We also have the ability to have a programming cost. The programming cost will be triggered for every unique model. So this way we can account for programming machines. In this case, we can set our programming cost to be around $100. We also have this expected production time, and if we want to, we can have an expected production time added with our lead time and our post-production time to give the customer a more realistic expectation of when they should be receiving the parts. In this case, what we can do is we can say it'll take an additional 2 days to machine the parts. Now we're able to get to the material specifications. So with the material specifications, this is just so we can analyze and give customers better recommendations on their parts. So the first one that we have is a minimum wall thickness. So this minimum wall thickness, we can display if parts are too thin, or if maybe we recommend a different technology for machining of the parts, or even different, maybe even just a different material. We also have the ability to change the machinability rate. This is how efficiently each material can be machined. So we have this automatically calculated based on standards for all of the common machining metals that we have in our database. But if we're very proficient at aluminum, we can manually go in and modify these values to better match our real world data. So it's a great way to modify DigiFabster's backend to match that real world data and get even more accurate quoting for your customers. If we need to account for work hardening, we can account for that. Then we also can account for any additional material that we need to add to the bounding box. So what happens is when we're analyzing for the right bar stock, what we'll do is we'll add 5 millimeters in all directions, and this will this is what the size of the bar stock will be analyzing for. Finally, we can also add in the price per the model surface area, and this is to account for the finishing passing on the part. Something typically around 10 to 20 cents is a typical ballpark number. In this example, let's use 12 cents. Now we can get into the material costs, and with the material costs, we can account for this for multiple different ways. We can work off of bar stocks itself, and with bar stocks, we can add in as many different bar stocks as we support. We can choose to charge off the price of length, price of the area, or just the squaring of the bar stock. We can also work with round stocks, or we can also work with just price of kilogram. So with this, we can set up a price per kilogram. We can say the density of aluminum is 2.7, and we can say that we're going to charge $10 per kilogram of material. It's a great way to set it up, depending on if we want the most accurate results. If we want to quickly set up a working algorithm that we can always modify in the future. Finally, we can get to our post-production. With our post-production, these are add-ins that customers can select to pay a premium to get them needed, if they need them. So for example, we can offer polishing. With polishing, we can choose to charge our multiple different metrics, including the model surface area, model volume, the bounding box, or just a per part fee. So we can choose to charge off the model surface area, charge 10 cents per square centimeter. We can set a minimum price of $10 per part, and we can set our expected production time of an additional 2 days. So it's a great way, again, for customers to figure out when they should be expecting their parts. If we want to, we can also rename this, and we can also add a note to the user. We can also offer grinding or other post-production options, and we can even add custom post-production options. A typical one of these is if we need special certifications for parts. So if we were to offer a certification, what we can do is we can say for a per part fee, there's a $100 cost for this special certification. So if we're working in the aerospace industry or the medical industry, and we need to work off this more strict certification, we can account for that as well. So once we save this material, we're going to go back into the e-commerce widget, and let's upload some parts and test out our pricing algorithm. What we can do is we can choose from the library, and I'm just going to choose this 3-axis part that needs reclamping. So we can choose that multi-axis milling. Inside the multi-axis milling, we're able to select the materials. We set up aluminum, so we can select this. We can choose that different tolerance. We can have that high tolerance option. We can see how this affects the price in real time. If need be, let's say that we wanted to have this part threaded, and we also wanted these holes threaded as well. We can automatically update that, and we can change the price in real time as well. If need be, we can change the priority. We can also have the part polished. Then let's say we need the certification on this part as well. We're able to analyze all of this and create the price for $468. We can add the part to our cart and then proceed to the cart. Inside the cart, we're able to see the model name, material, and all the specifications. If we want to, we can also allow customers to change the quantity at the step, and we can also automatically apply discounts. So if they're ordering in large batches, we can automatically prorate them as well. Continuing on to the next step is delivery. So with delivery, customers can add in their address, or they can choose a local pickup option as well. Our delivery system works with multiple different providers, including UPS, USPS, FedEx, DHL, and more. Continuing on to the final step is our summary page. And on the summary page, customers can add promotional codes if we wish to offer those. We can offer also a place for customers to add in notes. So if there are critical features on the part or critical faces, we can account for those. We also allow for uploading of additional files. And a lot of our shops recommend or even force customers to also upload engineering drawings. So this way, the shop fully knows exactly what the customer is expecting from their part. And then what we can do is we can review this quote pending review. We can quickly see what the pricing will be for the part, and we can even see the terms and conditions of the sale. Now, normally customers would be able to pay directly with credit card or PayPal, or what we can do is we can hold orders for review. So since this order is over a certain threshold, we can say this is an expensive order. Let's have someone on our end review it, see if we can maybe give them a discount or prorate it a little bit. So what we can do is we can submit this order for review. And now that this order has been submitted for review, what we can do is we can go into the back end. We can go into our orders tab. We can go into that most recent order. And inside this order, we can review the part. If we want to, or if we need to, we can fully modify the price at all. So we can decrease it to, let's say, $150. And then just like that, we can send the quote out to the customer. With that email that we just sent to the customer, they have the final quote along with payment instructions if they choose to proceed. So that's the super simple overview of our CNC milling module on how to set it up, the different types of milling, and how it works with our back end. At this point, does anyone have any questions or anything else that we can help answer?
I don't see any additional questions at this time, Michael.
Perfect. Well, I'll give it another minute in case anyone has some questions right now, and they're typing them out. Thank you so much for coming out to our webinar today. If you have any questions, feel free to reach out to myself directly, or we can reach out directly through our instant messenger. So inside of here, you can send a message, and you can talk to myself or anyone else on the DigiFabster team.
Okay, well, with that, that concludes our broadcast for today, and thank you all for attending.